Hi, my name is Christina McCutcheon and this is Phoenix Little, and we are going to talk to you about nuclear decay. So the first thing that you need to understand is how to represent elements using this form. So the X is the element, so you would use something like sodium would be Na or potassium would be K. And then the A is the atomic mass. And it's stuff in the nucleus. And then the Z is the number of protons in the nucleus, or if we're discussing electrons, it is the charge, the negative charge of the electrons.
The first type of decay we're going to go over is alpha. It's represented by the Greek letter alpha, obviously, and it's basically the expulsion of one helium atom. When you're going over how to do alpha decay, you would do the element that you started with on one side, and then on the other side you would have the helium atom, and notice that your atomic number and your both your A and your Z number have to equal the A and Z number that you started with from both of the atoms.
So the next form of decay is beta decay, and its symbol is the Greek letter beta. So this involves electrons, and electrons have no mass, so this number is 0 and this is -1, because they have obviously a negative charge. So again, all of these numbers have to equal the numbers on the left. So because there is not a mass, because electrons have no mass, the atomic mass stays the same on both sides. But because there is a charge, the atomic number changes, and so because the atomic number changes, the element also changes. So it changes from thorium to polonium. This is gamma decay, and it has the Greek letter gamma, which is very similar to beta. But the gamma, it has no mass and it has no charge. It's basically just a form of energy. So whatever you have on the left will be the same on the right. And then you just add the gamma particle on the left, on the right.
Okay, these particles are stopped by different things due to their varying degrees of strength. Alpha particles can be stopped by basically your hand, beta particles by a weaker metal like aluminum, and then gamma particles by a pretty thick sheet of lead. How you graph these numbers is different though. The alpha decay is represented by a horizontal line, a diagonal line. The beta decay is represented by a horizontal line, and you would graph it with mass number on your y-axis and atomic number on your x. For example, if you had polonium undergoing alpha decay, it would turn into lead because it would be lead 81. If you had lead going through beta decay, it would become bismuth because it now has 83 protons. And gamma on this scale is not represented because it's basically the emission of energy, so the mass number or the atomic number don't change.